Good afternoon, students. Today I am discussing about the electromagnetic induction. What is an electromagnetic induction? Listen, when an electric current produced in a closed circuit by changing the magnetic field around itself, then it is called induced current. And this phenomena, by changing the magnetic field, if electric current produced, this phenomena is called electromagnetic induction. Now listen, already we know that magnetic effect of electric current. Scientists Oersted say that if we take a conductor and some current passes through it, then around itself some magnetic field produced. That means if current flow through any conductor, then it becomes current carrying conductor. Then this conductor becomes current carrying conductor. Now if there is a current carrying conductor, then around the current carrying conductor, we can say C, current carrying conductor, around any current carrying conductor there is a magnetic field induced. So in that current carrying conductor, some magnetic field induced around itself if this conductor flows or carry some current. Now recently a scientist named Michael Faraday thought that if a conductor carries some current, then there is a magnetic field. So if we create a magnetic field, then there may be possible to flow some current through the conductor. If we reverse this process, that means here in Oersted experiment we looked at if current flow through this conductor, so there is a magnetic field induced. So Michael Faraday thought that if we induced some magnetic field around a conductor, then there may be inside this conductor there may be current flow through this conductor. Then Michael Faraday tests a experiment several times. He takes a conductor, a current carrying coil like that. He takes a current carrying coil and connect with a galvanometer. What is galvanometer? Galvanometer is a kind of a device which measures if there is current flowing through this circuit or not. It does not measure the value of the current, magnitude of the current, how much current is flow through this circuit. It only measures if there is any current flow through this circuit or not. And if there is any current flow through this circuit, then the direction of the current also measured by the galvanometer. It shows the galvanometer looks like a device like that. There is an needle, arrow types, and here 0 marks in that scale, and if this needle is fixed at 0 point, then it shows no current flows through this conductor. If this needle deflects, that means current flow through this circuit. If we connect this galvanometer with a circuit, and if this needle moves, that means deflects in any left side or right side, then we can say the current flow through this galvanometer, that means flow through this circuit. Clear? Now Michael Faraday tested an experiment like that. He take a coil of a conductor and connect with a galvanometer. Now he kept a magnet here. As he kept a magnet here, like North Pole and South Pole, he kept a magnet here. So there have some magnetic field around itself like that from North to South Pole. So as there is a magnetic field around itself, so he thought that there may be possible to flow some current through this conductor and galvanometer deflects. But he looks that there is no deflection in the galvanometer. That means current is not flowing through this coil. Now he thought if we change this magnetic field, he moved this magnet towards the coil. He moved this magnet towards the coil. When he moves this magnet towards the coil, the magnetic field, that means number of magnetic field lines, changes through the coil. When the changes occurs, that means when this magnetic field lines, number of magnetic field lines or magnetic field density, intensity, we can say magnetic field intensity changes inside this conductor, inside this coil, then the galvanometer shows the deflection. Now he tried to move this magnet towards this coil, and when they move till completely this magnet inside this coil, he looks that the current flowing stops. That means he puts a graph like that. If there is a current puts in the y-axis, and inside here the distance between the coil and the magnet, he looks that at first, as there is a distance between the coil, no current flows, and after some times current flows increase and galvanometer shows more deflection. At a certain time the deflection shows maximum. At a certain time the deflection shows maximum. After that the deflection radially decreases and stops. When this magnet moves completely inside this coil, the current flowing current stops. That means the current is not flows. After that, if he want to remove from this magnet from inside this coil, they take it for removing, then again this galvanometer shows some deflection. That means current flows through this conductor, and the direction of this galvanometer deflection is opposite of the previous. That means when they inserted this magnet inside this coil, the current shows in that direction. The galvanometer deflects in, if we consider the galvanometer deflects in right side. After some time, when he removes this magnet from the coil, the galvanometer deflects in the left side. That means current flows in the opposite direction. Clear? So from that he concludes that the galvanometer shows a deflection only when there is a relative motion between the coil and the magnet. The galvanometer shows a deflection, that means there is a current induced inside the coil when there is a relative motion, that means changes in the magnetic field lines between the coil and the magnet. And second conclusion is that the direction of the deflection is reversed if the direction of the relative motion between the coil and magnet is reversed. When he inserted this magnet, the direction of the current deflection or direction of the current flowing is any direction. If we consider when he removed this coil, the direction of the current is opposite direction. So he concludes that the direction of the deflection, that means the induced current inside the coil, is reversed if the direction of the relative motion between the coil and magnet is also reversed. And third conclusion is that the deflection of the galvanometer, that means induced current inside the coil, increases if the magnet and the coil are rapidly moved with respect to each other. If he rapidly moves this magnet and coil, then the deflection of the galvanometer increases. That means the current flowing through this circuit also increases. So it says that the deflection of in the galvanometer or induced current inside the coil increases if the magnet and the coil are rapidly moved with respect to each other. Clear? So from that he concludes that there is an induction of current if we change the magnetic field lines, if we change the number of magnetic field lines inside any current carrying conductor or coil. and that is called electromagnetic induction, and this current is called induced current. So we can say that an electric current is produced inside a closed circuit by changing the magnetic field lines is called induced current, and this phenomena for changing this magnetic field lines, if there is a current flows through this closed circuit, that is called electromagnetic induction, and this theory was discovered by Michael Faraday. Clear? Thank you very much.